I'd like to give us a chance to take another look at the length, area, and volume discussion. A lot of you succeeded with it, but there were a number of issues that cropped up. And so before we go through and grade this, I want to give everyone a chance to check their work to make sure that it's accurate. So let's go ahead and first review what the assignment itself was asking for to make sure we start off on the same page. The first thing that we'll notice that as we look at this is that it's asking you to round things. It says, first of all, the measurements of length, width, and depth of the room to the nearest centimeter. A lot of you kept the decimal point, and so like 28.4, well, that wouldn't be correct. You'd have to round that, wouldn't you? And then in part 2, it asks you to find the length and width of the resulting rectangle of smallest perimeter. Okay, so we'll talk a little bit about what that means. It doesn't ask for the area, though, does it? That's a different problem. And so, again, we have to pay kind of attention to what the question is asking for. Again, this should be fairly simple for you to correct, but I want to make sure you have a chance to check your work before I do, all right? Then finally, what happens when you place all those centimeter cubes from end to end? Clearly, that's going to be a major thing. We probably have a feeling that it's going to be large. We may not have a true feeling for just how large it's going to be. Now, this is a wonderful time for us to talk a little bit about how we can handle number using technology. In this case, I'm going to walk our way through this problem with a sample data set for a spreadsheet use. And in this case, the actual measurements or the number will be what we're acting upon. So we're acting upon number. This in turn was generated from your measurements. So if we back channel this all the way back, originally we start with the physical object of your room and some type of a measuring device. So you've done that. Your record of action is the number itself, the number you came up with. So we are going to be using this spreadsheet as a tool to act upon these personally meaningful numbers that resulted from your measurements using a physical object in terms of a measuring device. And so again, we are now taking a look at what this might look like. And these numbers are not just numbers at random, are they? These are numbers that came up from your use. You measured something. There's a concrete physical world thing that gave rise to these numbers. So let's walk through it. We'll go through a spreadsheet, and I'm going to take advantage of this chance to model for you some of the spreadsheet commands you might find helpful. So first of all, remember to round your measurements to the nearest centimeter. And it turns out the spreadsheet could help you do this, but you need to remember that when you do something like this, 304.6, well, that would round up, wouldn't it? 272.3 would round down, and so on. I find that spreadsheets are very useful, even at this level. Let's consider the following sample data. All right, let's say we have a room that was length 413.4 centimeters, its width was 408.9 centimeters, and its height was 275.7 centimeters. I copied that and I pasted it down here. Now what happened? How did I get this to look different? Well, if we right click, we can go up to number under format cells. So we're going to format that cell. We're going to change what the number looks like. We change the number so that it has 0 in terms of the decimal places. When that's done, that's the essence of rounding, and we have rounded these numbers now to the nearest whole centimeter. So again, spreadsheets can be used for many things. This is a little trivial here, but you'll notice that it can certainly come in handy, can't it? Our next question then was to find the measurements of the length and width of the resulting rectangle of smallest perimeter. And I told you something about that. That was that if you knew the total number of cubes, you could take the square root of that number and generate the square, and the square would have the smallest perimeter. So since we have the length, the width, and the height, we want the total number of cubes. Well, gosh, that's the same as the volume, isn't it? And so since volume is equal to length times width times height, it'd be very easy for us to compute what the total is, and I've done that. But I want to show you how that was done so you can see it and work with it yourself. At this point, I'm taking my mouse and I'm setting it aside. Everything from here is not going to be done using a mouse, but with the arrow keys. What I have found working with young people is they do much better on a spreadsheet using the arrow key and the left, right, up, down than they do with the mouse. It makes it a little easier for them to pick the exact numbers they want to act upon. So let's take our total, and I'm going to hit the equal sign. That tells me that I want to do something, dang it. And what do I want to do? Well, I want to select the length and multiply it by the width and multiply that by the height. And the only thing that has to be taught at this point is that the asterisk or shift 8 is how you tell a computer to multiply. When we look at what we've done now, we also see another thing that's very helpful. And that is that it's color coded, at least on my spreadsheet. And you'll notice that when we do this multiplication, I'll get my mouse back again so I can use it to point. You see over here, we're selecting the length, which is a blue color. So that's this piece right here. We're selecting the width, which is kind of reddish. You see how the colors match up? And we're selecting the height. And we can very easily compare what it is that we're doing in terms of the raw number and the actions we're taking on that number. It's easy to see right here. So this really lends itself very nicely. Once we know what these numbers are, we can act upon those numbers using the power of a spreadsheet. Now, we know that this is our total now. I just copied and pasted it over. And I gave you a little bit of information because I wanted that to be part of our commonplace. Remember now our commonplace, authority, reason, experience, right? I want part of our commonplace to be that the perimeter is, the smallest perimeter is found when you have a rectangle that is a square. So how can we find the length of one side of the square? What do we want that to be equal to? Well, if I say equal, the way we tell a calculator or a computer to take the square root, at least in this case, is SQRT. I'm going to select the number that I want to take the square root of, close the parenthesis, and there's my result. Again, my focus here is on the number itself and the actions I want to take on the number. I'm not worried about the calculations because I know the calculation is going to be done correct. What I don't know is that if I really am doing this correctly, okay, that's the mathematics. If I'm doing it correct, I'll know the answer is going to be correct. When working with young people, that allows you to focus on the concept, and you can always practice the process at another time, but you'll at least know from here the answer will be correct. A lot of you, for some reason, decided it would be fun to compute the perimeter, which I applaud, not a problem at all. Since a square has 4 sides, and since each side is the same length, if we multiply the length of one side by 4, we'll get the perimeter. So if we look up at the function bar, up at the formula, up at the top left here, you'll see where it says that is equal to the number 4 times C9. Well, what is C9? We see here's C, and here is 9 This number right here. 4 times that number gives me the perimeter. What we'll see about this, I think that's kind of nice, is that the spreadsheet allows us to act upon number and focus on what it is that we're doing. Again, very, very powerful way of using it in teaching. Finally, we're going to put all those cubes end to end. We're going to see what happens. How far will it go? And this is a real eye-opener. Because we know the total, if we put the cubes end to end, we know that that's how long it would be. It's that many centimeters, a pretty big number. Let's make it a little more manageable so we can visualize it a little bit. Because a centimeter is 1/100th of a meter, if I take this total number, divide it by 100, I'll get the number of meters. And so now it's starting to get a little more reasonable, isn't it? So I can take this number, divide it by 100 to find the number of meters. I then can take this number, since there's 1,000 meters to the kilometer, divide that by 1,000 to get the number of kilometers. Now, I'm perfectly happy if you leave it like that, but a lot of people are used to thinking in miles instead of kilometers. And so there's a conversion we can do to convert kilometers per miles. There's about 6.2, little over. I've got a more exact number down here in terms of how many kilometers there are to the mile. So if we multiply 466 times this conversion factor, what we find is it's approximately 290 miles long. Those little centimeter cubes from one room is 290 miles long. To put that into context, if we take a look at this graphic and we put UHD in the center, you'll notice that it goes way past Dallas, way past Fort Worth, almost into Wichita Falls. We're almost into San Angelo here. We're clearly all past McAllen, okay, way down in the valley. That's huge, that we could reach out and we could touch with the line you create from those little centimeter cubes. It's pretty amazing, I think, for young people as well as for us as older people to realize just the difference between length, area, and volume. The cubes that fill one room, if you put them end to end, can go from here to San Angelo. That is pretty eye-opening. I really encourage you to go back and to check your own work now that you've had kind of a walkthrough here with some representative data. Make sure your calculations are correct. Feel free to use a calculator. Feel free to use a spreadsheet. If you'd like to try and use a spreadsheet and want to try to reconstruct some of what we showed here, I think you'd find it's helpful for you. I think that what we are trying to develop is this notion that the object we act upon, once it's well understood, we can then use that understanding and really leverage things forward quite a bit. In this case, the number of cubes, is what we're acting upon with the spreadsheet. It's a little more advanced, isn't it? We're acting upon number, and that means we're using operations. In this case, the operations of multiplication and division in terms of conversions. Again, though, it has to be understood in order for the operations and the actions to make sense.